Hello, hi, good morning, good evening. So this is Mark Smith on the latest version of the Blue Water Thread, which is our second digital water one in this series. So today we're talking about mobilizing data into action. And I'm talking to you actually today from a hotel room in Singapore. Because I'm attending the Singapore International Water Week 2024, which starts really Wednesday, Thursday, Friday, but there's some visits tomorrow, and it's really interesting. Really looking forward to it. Now, one of the themes of the Singapore International Water Week this year is digitalization, and it's a theme that we keep coming back to. So I'm really looking forward to today with three fantastic guests and some good conversation. So before then, let's move on to some housekeeping. So as normal, your microphones are switched off. Please don't take that as to be just passive listening. I'm really hoping that people get involved. Please ask questions through the chat. And I think where we usually get some really good questions through. So I'm hoping that will happen again today. So we also run all digital on the social media channels. So please use the hashtag the Blue Thread. And going forward, please introduce other people to this webinar so that we can keep building it, building our audience, and keep going forward. So next slide, please, Jay. Okay, so apologies. I think there's a delay on this, and I think it's essentially down to the lack of the Wi-Fi I'm currently operating on. So I think it's not as seamless as we normally have. But please bear with us. So as I said, today we have three terrific speakers. We have got Paul Horton, Amy Jones, and Tom Allen. I think both Tom and Paul you've heard from before, whereas Amy is new to this webinar series. But I think they're all really interesting anyway. So we're going to the order that's on the slide isn't exactly the way we're going to go forward. I think Paul's going to lead first, then Tom, and then Amy, and then Tom. But first of all, just a few thoughts from myself. I mean, digital water is something that touches everything. Every single conversation I have nowadays seems to be about ultimately data, the use of data, telemetry, AI, and I think rather than it being a sort of panacea for all our problems, I think what it is it will certainly be part of the solutions going forward into the modern water sector, but I think it'll bring a whole load of problems with it. Some of those we will explore today, and I think Paul is going to start that really by trying to, it's almost like a call to action. You know, we have got big issues, and we have got big data sets, but to be able to mobilize those data sets to solve those issues, we need to think about data privacy, security, governance. It's not just a case of get all the data, throw it into a sort of a big system of AI, and suddenly we'll come up with all the solutions that we want. So I think that's really something that Paul wants to explore. So let's start with that. Paul, as you know, is the chief exec of the Future Water Association. Perhaps Paul could join me on the screen, and has been involved in this area for a long time. He's also very passionate about cybersecurity, something, Paul, that we've talked about many times, as well as other things. And I think has got a really good, through the Future Water Association, which is a trade association of 120, 130 members, primarily but not exclusively in the UK. I think he's got a really interesting and unique sort of view across the whole sector in terms of how this looks from the supply chain. So maybe, Paul, you can kick it off and try and sort of set the scene at a sort of maybe fairly macro level, and then we'll drill down into it with Amy and Tom. So over to you, Paul.
Thanks, Mark. I'll just see if the technology works. Yeah, so we've got, when you look at data, I think what gets lost in the mix is what sort of data we need. What is it we're looking at? Why are we looking at the data? And what does it mean? you know, as Marcus, you just said. So I'm going to try and frame things into a scene setter. I will focus on the UK, but I'll throw some international data sets out there in terms of a comparison. One thing I usually start my presentations with is that, you know, let's stop talking about climate change. It's there and it's happening. We've breached 1.5 degrees for probably the last 13, 14 months. It isn't a trend, so we've got to think differently. We've got to adapt. And what this all means in practice, we're already getting the lowest maximum level of Antarctic sea ice. We're getting the highest global temperatures. Again, this is all information. This is all data that feeds into how we manage systems. And when you get onto the global assessments, be that at the UN level, be that the European level with the European Environment Agency, water scarcity hits every bit of understanding, research and knowledge that we've got, and that's before we talk about flooding. So data's critical, as Mark has said, and just a couple of things. In the last sort of 12 months, we've generated about 120 zettabytes of data. I had to look this up. What on earth is a zettabyte? And as you see at the bottom, a zettabyte of data, 1 zettabyte, is equal to 1 trillion gigabytes. So just try and put that into your minds, and it's meant to get to about 175 zettabytes per year by 2025. This is a big number. What does it mean across a broad range of categories? And I've sort of done global and UK, and you can see there the similar. And it's probably because countries are collecting broadly similar data sets, and some will collect more in certain areas. Water sits there as the lowest across what are the critical infrastructure categories. And when you look at sort of 2019 to now, if we come back to a UK context, there's just a few figures in terms of what this means across those critical infrastructure categories. So in terms of additional information over the past few years, we're now talking about 1,000 million gigabytes of extra data. Water, although it says that it remains stable, yes, it has, but we've collected a lot more information. So we're now dealing with 20 million gigabytes of additional data since 2019, 2020. And if I flip, and I'm using this slide to reference something Future Water produced, which is a skills style report card across 8 main themes. Everything from leakage, asset health, people, sewer maintenance, innovation, and research. And there's a reason I'm dropping that in now, which I'll touch on as we get into what I feel are the critical data sets. And just to give you an example, the top diagram there on this page shows you the sort of scores and school style report card scores that we had. So in terms of asset infrastructure, we're not doing well, and we need to collect more information to understand the challenges that we've got and where we're failing. So what does it mean? Well, I mentioned climate change, I mentioned all the data we're collecting, I mentioned other things. Why do we need these data sets? Well, if you start to look at things, like water quality, then we need more real-time data. We need more what we might call advanced analytics. In terms of resources and resource efficiency, well, we're talking there consumption patterns, leakage, etc. Infrastructure, well, that brings in not just asset management, but predictive maintenance. What figures can we pull out from there? And all of these start to feed into data insights that should, in theory, shape policy. And then, of course, we can, with demand forecasting, with process optimization, that's the efficiency side of it. And I touched on the climate impacts earlier and what we need to do in order to record the information that allows us to update, support, do something clever with our infrastructure so we're able to adapt. But what are the challenges? Mark's heard me talk about this a lot. Too often we work in silos. Too often data's collected, say, just for leakage, and there are other data sets which aren't handed over that could lead to things around operational efficiency or other areas of performance. Standardization, this is one that I jump up and down about all the time. If we're collecting data sets, we should be collecting the data in the same way, the same format, the same structure. And that's not the case. And we don't even necessarily have standards around there. And Mark mentioned governance early on. That's definitely a problem. And of course, the water sector deals with lots of legacy issues, as I call them. So, we were collecting data on pumping stations and treatment plants 30, 40 years ago. We haven't necessarily updated all of that. So it leads to inconsistent data, and inconsistent data then leads to misinterpretation. And that causes challenges at the regulatory issues side of things. And of course, if you don't get the data right, interpret it correctly, you then struggle with all the issues that link to resources. And a whole number of resources fall into that category, including workforce. So where do we go with this? Back to what I mentioned in our report card, if you're looking at the UK, the critical infrastructure is underground. So we need to collect better data around standards and who's implementing what standard and what do those standards mean. We need a lot more around cyber, GDPR, etc., particularly as we need more data to make us move towards a more resilient system. We're still not collecting everything around leakage. We don't meter everybody, so the challenges there. Emerging talent, well, that all links to the whole EDI agenda, where the data is very mixed, and again, we're not properly collecting it. And innovation, we're very good at talking about innovation and understanding what we need, but if you apply the IP lens and look at innovation again, it tells a different picture, but we don't use that metric. So it's critical data required that currently we're not delivering on, we're not creating. So solutions, wouldn't that be great if we could solve everything overnight? We have to move towards more unified data systems, and in interoperable data systems, in the sense of we're collecting information that's valuable across not just water but infrastructure generally. So the water sector is vital to the energy sector, telecoms is vital to water. So we need interoperable data systems and data systems that make us understand not just what's happening in the water network, but the implications that has on the sewer network and sewer systems. We need to be better around what I call the IT IoT world. Yes, we collect a lot of information, but we don't necessarily use it. I step back from the world of AI and I talk more about machine learning, because the reality of where we are, AI systems, machine learning systems can help us generate information that starts to plug those data gaps. We're not there yet where AI is in that place where it can help us run systems. Data governance, Mark mentioned this earlier on, is essential, and predictive systems. If we're getting inconsistent data sets all the time, then prediction becomes a real challenge, and you have to constantly question what it is you're predicting and how successful that can be. So there's a whole, let's restructure, let's rethink, let's bring this all together and start to say, here's the way forward. Here's where we are. It's not right, it's inconsistent, but we can turn this around and get on top of the information that we need. And that can start to help us be a lot more adaptive to the way the climate's changing, but generate a lot more information that's useful across the whole of the water sector, but also across other critical infrastructure sectors. And if people want to follow up on this and some of the ideas I've thrown out there, my email's there. That's Mark.
Yeah. Thanks, Paul. I mean, where to start, to be honest? There's so much. First of all, I've never heard of a zettabyte before, which I think is an interesting. What was it? 1 million gigabytes? Is that what you said? Is it?
A trillion.
Trillion.
Trillion
that's interesting.
Yeah.
What's more interesting, though, and I wonder, is this driven by the commercial environment in water, is the lack of progression on data sets. 4% or whatever it is in water. Does that show lack of investment? Does that show lack of cohesion? Do you have any thoughts on that? Because it seems to me, the one thing everyone knows and agrees is that we cannot survive without water. And the second thing everyone knows and agrees is that we don't invest enough in it. So, and that's now borne out by another data which I quote, which is 4% of critical infrastructure data. So, I don't know, any thoughts on that?
Yeah, it's water's always been, what's the phrase I use? Safe. Therefore, it's been looked after. We're treating it. We're doing all right, so we don't need to worry too much. I think you're absolutely right, Mark. When you compare water to, say, healthcare, which is a comparative that I always look at, because they do some clever stuff around innovation observatories and things, they're at 25 to 30% because it's linked to the health of populations, and that's across the world as well as the UK. So they're collecting data all the time, which is allowing them to get better, more information, do more focused healthcare. And we're sitting down at 4%. Well, if we collected much more data with a bigger part of that infrastructure, how good and clever would we be about managing catchments and ecosystems, and not just water quality, but everything to do with flooding, flow off from land, etc. And water's, if you get clean water and sanitation, you have a much bigger impact on healthcare than all the clever things people are doing with DNA analysis and other forms of treatment. So I think it is a shame.
Yeah, I think, sorry for putting across, it is interesting that the single biggest advance in public health was not antibiotics, it was water, right? And the investment in water came before the investment in healthcare, right? And now the investment in water has been pushed to the back of the queue. And we're now talking about modernizing legacy systems and infrastructure. Do you think that's essential to drive better data analytics?
Yeah. I mean, we're still, yes. Right, take a step back. Yes, why? Because we're dealing with often legacy systems. You might call them outdated, but it's because the systems, the pipes, the pumps, etc., pumping stations, have all been there for 40, 50, 60 years. Have they been updated to reflect where we are now, where we have to adapt constantly and on a consistent basis with the way the climate's changing? No. And do we know the state of those systems? Can we say 100% certainty almost, wow, I know what's going to happen on that bit of pipe network tomorrow? No, we can't. So we absolutely need to get those systems back up to speed, collecting much better information as part of the way forward. And I'll just conclude with the CSO example, where the rush to put monitoring systems in place, be they event duration monitors or other forms of monitors, has been so politically pressured that a number of those systems haven't been put in the right way. So we're collecting poor data that makes no sense, and that unfortunately then gets into the press. So we have to upgrade our systems.
I guess ultimately the other one then is you've got that dichotomy between ensuring broad access to data and sharing and collaboration, which is the probably, what's the word du jour or whatever, forget my French. But how do you do that while also sort of effectively managing data privacy and security? Do you throw it open to everything? Because, I think a lot of people are very worried about, hacking, which seems to be a modern sort of thing. And yet we need to open these data sets to be able to allow people to build solutions. So how do you see that working?
So I think my own feeling, Mark, is that we overplay the GDPR thing. People aren't going to look and say, oh, look at the water use here in these block of houses. Oh, that's so that must mean X, Y, and Z. I don't think that is an issue. What is an issue is that opening those data sets allows people to come and have a look at what's happening and offer views. And there could be views from outside the sector, not just mathematicians, but people who just think differently. And we have to build in the wider social dimension into this. And without that data being open and accessible, we're not necessarily understanding the social implications of water use. So I think we we have to be careful, obviously we do, but I think if we're over careful, which is another challenge the water industry has, we won't be generating the insights that we absolutely need going forward.
Okay. Well, you won't hear me making the case for better, for stricter enforcement of GDPR, but that's for other reasons. So, thank you very much, Paul. And if you could just hang around for a bit of Q&A at the end, I'd really appreciate it. So, next up is Amy. So, if Amy could turn, yes, hello, hi, Amy. Great to see you.
Yeah.
So, Amy is a chartered senior consultant at WRC and has over 12 years' experience in the water sector. Particularly in regard to the impact of urban drainage on the environment. And she's worked in asset management, environmental permit compliance, etc., etc. She's going to talk, I should mention, she has a PhD from the University of Warwick in pollutant mixing and a first-class master's degree in civil engineering, as well as French. So we could do this in French as well, Amy, but I'm afraid the conversation would be very, very short.
Probably.
So I think really, really interested in the two things that when I look at your site is about the automatic image labeling on the eyes on the water. I think that's something. And then perhaps you're going to talk to us a little bit about a really exciting large investment beyond the Ofwat Innovation Funds on I love the name, River Deep Mountain AI. So I'll hand it over to you at this stage and I'll come back to some questions in a minute. Over to you, Amy.
Fantastic, thanks, Mark. So as Mark mentioned, I'm going to talk today about a couple of projects that WRC is involved with, which are using AI, or more specifically machine learning, to understand water body health. It's a very quick fly through today, but my email address is on the slide and at the end, and I'm happy to take emails after today's webinar if anyone wants any more detail. So the first project that I'm going to talk about today is called Eyes on the Water. So in Bradford, there's a community group called the Friends of Bradford Specs, which is very hard to say, so I'm going to just stick with FOB from now on, but called FOB. And over a period of years, they've collected around 100,000 photos of the becks, the rivers that flow kind of under and through the centre of Bradford. Those images are great and they offer lots of insights into kind of how healthy the rivers are, but analysing them is quite a painful process if you try to do it manually. So what we tried to do through this project was explore whether machine learning could be used to kind of automatically tag those images and see what they tell us about river health. What markers of river health do they show? There's a slight lag. Okay, well, we're on. So these are that you can see on this slide, the kinds of things that we sort of looked for in the photos. So there are 9 kind of overall categories that you can see there. Each of these had subcategories. So in total, I think there were 22 different markers or things that we were looking through in the photos. And these were based on things like the Water Framework Directive, so legislation that sort of says how healthy a river should be, essentially. Bit of a literature review and kind of WRC's previous experience of doing kind of water quality studies. So just kind of picking a couple of these out just to talk through kind of what I mean. So top left there, you've got outfall. So this is kind of an indication that we've got a flow that's coming into the river that could potentially be a source of pollution. So kind of useful to know where all of those outfalls are. Just below that, you've got obstruction. So this particular example probably isn't big enough, but in some catchments, you could have quite big obstructions that prevent fish passage, for example. So you can't kind of get wildlife or can't get fish at the sort of upper end of river reaches. And then we did look for some positive signs of river health as well. So at the bottom there, you've got wildlife. So we also looked for wildlife in the images as well. I think collaboration has been mentioned a few times already today, but it was kind of really vital to this project, so bringing together different expertise. And I just sort of wanted to talk about how the project was delivered. So through the first phase, WRC used its kind of experience of water quality studies. So we gathered all of the photos from the community group. We set up a database, a kind of an index of all those photos in it. We found a sort of automated way to remove personal data from the photos. So although GDPR can be problematic, we still have to kind of comply with it, and we spent quite a lot of time trying to do that for this project. And then there was a kind of manual labelling process as well. So some poor souls at WRC had to kind of go through and manually tag the photos so that we could then use them to train the machine learning model later on. The actual model development was delivered in 2 phases. So for the first couple of months, we worked with 25 students from National Taiwan University who were absolutely phenomenal, cannot recommend them highly enough. And they tried lots of different machine learning models to see how effectively they could pick out these markers of river health in the photos. The best models that the students found were then kind of refined and improved further through a second model development phase, which was undertaken by a company called, or primarily by a company called Rain++, through January, February 2024. And then the final models, WRC then kind of took them. We really wanted to make these models open so that other people could kind of take them, apply them and learn from them. So we did a bit of work to kind of make sure that the code could be understood and readily used. And then we applied the final model to the full data set that we had, all of the photos that we had in Bradford, to see what they told us about river health. The project was funded by Natural England, and should say as well that we had input from Yorkshire Water, from the community group themselves, and from the Environment Agency as well. So they provided feedback on the models so that we could check that they, you know, it was telling us useful information, or it's telling lots of stakeholders useful information. Bit of a lag. So I'm not a data scientist or a programmer, but I was conscious that this webinar is about digital water and that there might be some very technical people on the call. So for their benefit primarily, yeah, there are 3 different machine learning models that were tried to ChatGPT, which is, well, you've probably all seen in the headlines, media headlines, CTRAN and YOLO. The slide, the sort of images that you can see on the slides there are from the YOLO model, so which I kind of particularly like because it sort of draws bounding boxes around the features that it's identified. So really useful for kind of talking to citizens about what the photo showed and for other stakeholders as well. Each of these models had different benefits, and yeah, probably won't go into those in detail in the interest of time, but they are on the slide. I mentioned that we've made the code openly available, and yeah, critically, I suppose, I think, yeah, was it Mark or Paul? Anyway, one or both of you mentioned like the importance of accuracy and quality, and so I think we've proven through Eyes on the Water that this kind of approach has potential, and that it can work, but we're really keen to kind of gather more images and further improve the models before they can kind of be operationalised, I guess, or applied in practice. And we've recently received funding from Natural England to kind of do that work, get more photos, manually tag them, and try to improve the accuracy, precision recall of the models. Here we go. So nonetheless, we've applied the final model to the full data set that we have for Bradford, and I'll just talk through some of the results now. The whole theme of today is about mobilising action. So should have said earlier, I think it was summer 2021, the community group, Friends of Bradford, FOB, I'll just stick with FOB, Friends of Bradford Specs, worked with Yorkshire Water, so FOB provided photos to Yorkshire Water that helped them to identify sewer misconnections, and those Yorkshire Water then went out, investigated the sewer misconnections and fixed them. So we know that these photos can be used to mobilise action, but the reason that kind of isn't business as usual at the moment is because it was taking so long to manually review them. Well, that's one of the reasons, is taking so long to kind of manually review the photos. So we know it can work. And yeah, just a couple of examples of the results that we saw when we applied this model to all the photos of Bradford. So what have we got here? Yeah. Okay, so the yellow diamonds sort of show where we found discoloration, so signs that the colour of the river had changed, which might be a sign of an import or some potential source of pollution. I actually don't, I mean, it shows discoloration throughout. I think this is just a sign that we perhaps need to look at the nature of that discoloration, like what colour is the beck, how does it change, in a bit more detail, but nonetheless interesting to see that it occurred sort of throughout the Bradford catchment. I should say as well, the river flows from kind of left to right at the bottom and then bottom to top, so it's kind of a right angle. Modified channel as well, that's kind of interesting. So a lot of the becks that flow through Bradford, they kind of have these steep-sided walls and concrete beds, which is not great for the health of the river, like benthic invertebrates, things like that. And we can see kind of the extent of that from these results. So perhaps a sign that some sort of river restoration or restoring it to its natural state might be helpful. I'm going a little bit quicker. Yeah, this next set of results then. So the orange sort of rectangles show where outfalls were spotted throughout the river reach, and you can see that some of those are near to red circles, i.e. signs that there are like rags in the river. So that might be perhaps an indication that the water company or the local authority have like a screen that's not operating as well as it should to kind of catch the debris, or that it needs to be cleaned. So a couple of ways that this kind of approach could be used to mobilise action. And I'm getting reminders that I'm going over time, so I'll go a little bit quicker and move on to the second project. So this one is very hot off the press. Very recent project win that's going to be starting in July this year, a project called River Deep Mountain AI. Sadly, I can't take credit for the beautiful title. So I suppose similar to the first project, this is a real collaborative effort again. So it's bringing together 7 UK and Irish water companies. We've got kind of data science expertise from Cognizant and Tidal. Xylem is involved for their kind of water quality monitoring knowledge. And then we've got 2 RSK companies who are heavily involved as well. So ADAS offering that kind of agricultural perspective and WRC for wider catchment management. Plus Rivers Trust and Stream as well. And the quote you can see on the slide is the kind of strapline for the project, I guess, but it's going to develop open source, scalable digital models that will inform effective action to tackle water body pollution, which is a whole load of words. But if we look at what they mean in practice, here we go. So there have been, lots of kind of academic studies and local pilot projects that have demonstrated how AI and machine learning can help us to understand water quality issues. And this slide shows kind of a handful of those. So in the middle at the top there, you can see eyes on the water. At the bottom left, Xylem, one of the companies involved in the project, has partnered with a company called EOMAP to show how satellite imagery can be used to look at spatial and temporal variations in turbidity, so like the cloudiness of water bodies. That's another example. And then top left, phosphate concentration is something that I believe is difficult, if not impossible, to monitor continuously, so to get that kind of understanding of how it changes in time. So if we can find kind of proxy parameters that indicate phosphate concentrations in a water body, that could be very beneficial. So Cognizant and Northumbrian Water have done an initial pilot study that has shown that has potential. But what we're trying to do through River Deep Mountain AI, which is quite big, I should have said, it's had sort of £5 million of funding through the Ofwat Innovation Fund. What we're trying to do is take these sort of pilot studies and enable them to be implemented at scale. So yeah, big challenge to come, starting in July this year. Nearly finished, last slide, promise. So just to sum up then, a couple of case studies showing how AI can mobilise actions to improve water body health. Mark, I think you said at the start that it can be seen as like a panacea that will solve everything, but maybe that's a bit too simplistic, and I completely agree. There's all sorts of challenges that we need to think about carefully around the governance of the data security, and so on. And finally, just that for both projects that I've spoken about and more widely, I think, and as Paul mentioned, understanding what the data means, it's really vital to bring together lots of different skills to do that. So your subject matter experts, your data science, and your communication, kind of people who can communicate all of those things effectively. And that's it. Apologies for slightly running over.
No, that's fine. No, apologies. That's right. No, fascinating, Amy. Talk about learning things. Friends of Bradford Becks who knew they even existed, but I know Paul Horton will be delighted, being a proud Bradford man.
Yeah, 1,000 members on Facebook apparently.
How many?
1,000 apparently on Facebook.
Well, that's really interesting. And one of my questions is going to be about citizen science. And I think this really is citizen science. So the downside seems to be immediately, one of the obvious things is how manually tagging the photos. I mean, that's got to be inefficient in this process. And I'm guessing that's not, it doesn't take genius to identify that. So is there, what progress is there in sort of skipping that step or maybe moving that forward faster?
Yeah, so we've had lots of thoughts and discussions about that. So one current thought, not sure if you've seen, but the River's just organised something called the Big River Watch. So they've developed an app where citizens can take photos of their local river, and I think they run that twice per year at the moment. One thing we've been talking to them about is whether you could embed this model into that, so that it tags the photo and then a citizen can say, yep, you got your models right, or no, your model's wrong. So it's kind of enabling that feedback loop. So that's, one option. But yeah, ultimately, I suppose the humans are still needed, which I guess is good for all of us humans, right? But
I think so.
Yeah, but some level
the second
of
question
human, I guess.
Second question is more interesting. Why Taiwan? I mean, I suppose you could say, well, not Taiwan, but I'm just curious. Why Taiwan?
Yeah, no, it's a very good question. So particularly here, they have a really interesting course over there called Computer Aided Engineering, which, so the students that we were working with do that course where, well, particularly they embed kind of AI machine learning into their engineering degrees. So the expertise are there and they're really good. I'm sure there are kind of similar organisations in the UK and things like that, but we've worked with them on a few things and have been really impressed by their data science skills in particular. So it's a pleasure to work with them on this.
I mean, it's really interesting collaboration between the sort of environmental expertise that you bring and the data science that they bring, and the need to actually keep pushing this forward all the time. I think sometimes it's a little bit worrying how the downfall of having to tag the photographs is very similar to some work for many years in WRC did on CCTV, work in sewers, where the fight from grading in sewers. And I do remember some poor souls having to spend hours looking at CCTV footage just for thing. I would have probably moved on from that, but I suppose
I think over time, perhaps, a long way to go. That's, I guess, over time as we build up these kind of more complete data sets and the manual, that manual bit's been done, it'll hopefully get easier as we go on. But yeah, that's where we're at the moment.
Okay. Thank you very much, Amy. So hopefully, again, you can stick around for a few questions at the end. And I'd like to introduce Tom. Tom Allen. So as our last speaker today. So Tom, hi Tom. Good to see you. Every time I come to Singapore, I have to get you on the webinar, so that's terrific. And really looking forward to what you've got to say. Now, Tom, for those of you that haven't met him before, the head of digital water at the Centre for Sustainability of Excellence here in the RSK Centre in Singapore, and has been involved really, probably, I suppose, far more at the forefront of driving digital transformation. And I think what you're going to do, Tom, is try and show some use cases where you actually have taken data set, applied AI to it, and come up with some sort of outcomes. Given that the whole webinar is about mobilizing data, we seem to have spent some time talking about the poorness of data, the paucity of data, and the difficulty in mobilizing it. So maybe you can help us a little bit with that. So over to you, Tom.
Thanks, Mark, and thanks, Paul and Amy as well. It was really good, interesting presentations. Hopefully I can get control of the screen. Okay. Okay. So, I just wanted to basically start off by talking about the different stages from that data to the action. It's something we talk about a lot. It's gone a bit far ahead, but it's okay. So we start on the left-hand side with data. So that's your raw and very, it can be unstructured or structured data. Apologies, I'm not sure why my slides keep magically going to the next one. There's obviously an AI gremlin in the system somewhere. pushing me on to the next one. Yeah, this is
So Tom, can you hear me?
I can hear you, yeah.
Right, there's a delay in the slides here, so apologies for that. Which slide do you want, the first one or this one?
Yeah, it seems to just be pushing all the way through to the end.
Okay, so can we go back to Tom's first slide, please? Just give us a second, Tom. Sorry. Apologies to everybody listening. This is the first slide you want, okay? So I think you better say next slide when you're ready to move on to it. If we would stop moving forward.
Yeah. Yeah, apologies about that. Maybe Marie or Danielle can help, because it's just pushing all the way through to the end of the slides.
Are you clicking it, Tom? No, you're not. Okay. So can we go back to Tom's first slide and then just let him tell us when to click through, please? Tom, perhaps you can just talk with, with the slides. Apologies, and maybe those in the back can help.
Okay, yeah, I'll just talk through. Maybe if we just share the screen, I'll just present it, not in slideshow mode. We'll do that one.
Could we go full presentation mode and just have it showing the next one? If we just click out full presentation mode, please, Jay. There we go, just leave it like that. Thank you.
Okay, at least I can talk through the slides now, so apologies about that. So yeah, you're starting from the left-hand side with a very kind of raw, generally like own process data. There's going to be a variety of different sources to collect that from, but ultimately that can be quite hard to interpret, merge together and analyze itself. So, humans aren't particularly good at looking at data. We're quite good at looking at information. So that's once it's been processed and formatted. It's generally had some kind of data quality processing come through it as well, so it can be a little bit more trustworthy. It can start to be visualized, and again, this is something humans are quite good at. We're very good at spotting patterns and things that stand out in this sort of level of information. And at a small scale, that's fine. If you think about why Excel has managed to survive all these years, it's because it's very easy to understand very quickly by people. And we shouldn't lose sight of those kind of things, like how people actually want to access and interpret the data. But it can result in slightly isolated decision making. So we try and push people through all the way into the next stage, which would be into insight. And that's where we start to add in the domain knowledge. So Amy made a really good presentation about how lots of different companies are coming together to bring their domain knowledge and adding even more insight to this information. We start to then add in time analysis as well. So that's the historical trends, but also the forecast as well, predicting what's going to happen. It can be complex. It can be higher value in general, like the results of that insight that comes out. So ultimately, the reason we're doing this all is to make those actions, and they can be quite a range as well. So I think this is important that we talk about actions from data. We try and structure them in a way that is both at a local level. So what's like an immediate action? So, if something is, a pump is going to fail, you want to make that decision, almost immediately. Whereas those longer term strategic decisions could be like, what pump do you want to buy in the future? Which is where we, have a range of actions coming out of this data. But whatever happens, whatever action is taken, it needs to be pushed into a feedback loop, and then we need to learn from those actions, and then the flow starts again. We start to collect more data. Based on time, we'll move on to the next one. Into the next slide, please. So we started to show this with our visualizations, working on a number of projects internationally, where these can be taking huge data sets, but just making them accessible and visible to people who really have that domain knowledge, so they can then add their own insights and take their actions based on that. And at this stage, we're still talking about probably something that's been going on for the last 10 years. We're not necessarily talking about the AI step at this. We're talking about taking all that data and being able to visualize it and understand it in quite a human form. So making it easy to be accessible. And some of these reports that we're showing, they contain 25 million records that we're able to instantly visualize, and people can customize how they access and action that data off the back of it. When it starts getting to the next stage, and we're adding in more complex data sets, this is where the potential and possibilities of AI comes in. But before we run into like just throwing raw data and raw information at AI, we need to build a sort of foundation and journey to get to fully utilizing it. So we go on to the next slide, please. Thank you. So in terms of the AI roadmap and building the foundations towards actually using it, if we start at the bottom with that kind of that source foundation, so we need reliable data sources. Without reliable data sources, the integration effort, any integration effort is going to be unsuccessful. If it's making decisions based on bad data, then those actions are going to be potentially damaging. So moving up the stack through into having good data quality, actually having somewhere to store this data, and then having access to that data. It's only really once you've built those foundational blocks that you should then start to integrate the AI technology and see the benefits that can bring. So if we go on to the next slide, I'm a bit conscious of time. Overrun too much and save some time for questions and answers. So we're developing a kind of range of AI technologies, and it's such a broad term at the moment. But what I've tried to do is highlight some of the ones that we are exploring, both internally and externally. So AI is the kind of umbrella term, but then things like the large language models, things that people are probably quite familiar with now, like GPTs, but that can help with tender assessments and proposals and bid support. So you're still applying your domain knowledge and your skills to that, but helping, using the technology to really speed up and make that a more efficient process. Generative design, at RSK, we do a lot of design work in construction projects, and coming up with new creative designs in a fast but robust way is potentially quite transformational to that. We've spoken a little bit about predictive models and data analytics already, and then Amy's great presentation on computer vision as well. So the kind of video and image assessments is something that can really speed up a lot of manual work, which is really this final slide. If we can go on to it, I'll just summarize the final one that we've done. So it's similar to the river image analysis that was mentioned earlier. Ours was potentially slightly less glamorous, which is analyzing toilets. So again, we, as humans, if you ask someone, is this a seat toilet or is this a squat toilet? I'm sure you could work it out pretty quickly. But as a human, do you really want to go through nearly 9,000 images of toilets and assign them? So we built an automated model to take all those images, run it through an AI kind of vision recognition software, which we built kind of within our own platforms. And one of the things that was quite different about this is that there's no necessarily like training data. This was a prompt-based assessment, so we're using kind of pre-built prompts to say like what type of toilet this is, not just is there a toilet in the picture, but what type it is. And then what we do is we validate some of those results initially, and then update and tweak some of the prompts that we give the AI model. So you know, you can see some of the confidence levels that it's detected, which, you know, for a project like this is acceptable. And if we think about the context, it's not just about analyzing the image, it's about saving the time of the people. So you could make the argument to say when these toilets were being surveyed, they should have a checkbox on their form that says whether it's seated or squat. But actually, why do we have all these checkboxes and forms to fill out as surveyors? All they need to do now is really go and take a picture, and then we can ask the questions to the AI at a later date and come up with new questions. We're not necessarily tied to this really rigid form at the start of the design process. So yeah, I think it's both time saving, but it's also kind of going to revolutionize the way we do project management as well. I'll leave it there, as I think I'm out of time, and hopefully it's some time for question and answers as well.
Well, thanks very much, Tom, and apologies for the issues with the slides at the start, and apologies to the attendees as well for that. But just because to show before we have to solve AI, we have to solve some software issues. Something that strikes me, you know, basically I could sum your whole presentation up in don't jump on AI. As you know, immediately get your data sorted, the sources, the quality, the storage, the access, etc. Do you feel that companies are almost looking at AI as a way of somehow getting over their issues with data quality? Do they think it's a sort of way of avoiding that essential spend? In other words, is there danger we're going to build on a block on a bit of sand here, really, not put the foundations in?
I think that is obviously always a worry, that you're plugging bad data into a model, and that's why it's really important to have test environments, and before you take real world actions, you simulate what actions you are going to take and what effect that would have on a process. I think it's about the risk of the project. So, you know, whether a toilet is seated or squat is not a particularly risky decision, but a chemical dosing level within a water treatment plant is a very critical decision and to make. So your confidence level in the AI needs to be a lot higher. I do think that I've been always a fan of trying to visualize and see the data to work out its data quality first, but again, it has to be within a protected environment.
Okay. So maybe Amy and Paul could join us for the next couple of questions, because there's a few come in. One is basically on what skills do we need within the industry? Maybe we can reduce the slide. We can remove the slide off the screen as well. What skills are we talking about? Because essentially, there's a need for data skills, there's a need for AI skills, but there's a need for basic environmental engineering skills, and who should be making these decisions? Which is sort of, because the new thing and the new kid in town is the data analyst or the IT director, and there is a bit of a concern around IT departments and companies being more focused on the software onboarding, forcing a one-size-fits-all approach rather than a more open versus software, but focus on the data output. So maybe Tom, you could start with that, and then I'd be very interested in what Paul and Amy have to say about that one as well. Sure.
Yeah, I mean, I have the privilege of working on both sides of the fence. I spent a long time in IT and then a long time as a data manager outside of IT. And I think they are quite different skills and priorities. And if we're to talk about data and action and analytics, then you don't want to be worrying about, IT tickets coming in as well at the same time. You want to be dealing with the data, not with IT and software. And I think that's really important to kind of give people that headspace to go and explore the data. And I think the skill set is kind of like being a 5-year-old. It's asking the why question 5 times in a row. and always like getting to that next level of what's going on within the information that you're seeing.
But I think that's very true, Tom. But unfortunately, I think not unfortunately, that's me. That's my prejudice. I think, Paul, you spoke about unified data collection and data governance. That really is seen almost universally as being the remit of the IT department, and yet the IT department is probably more focused on that side rather than data outputs. So how do we build this collaboration almost between the companies, not mine between companies?
Yeah, thanks, Mark. I touched on silos as well. So you've got something Tom said. You've got to be careful in terms of dosing, but you don't have to worry too much if you're just looking at when you might need to go and see, a treatment plant or something else. It's the mix of skills. So you need people who understand it because that's what they do every day. So they're very much the operations people. Yes, you need the IT people, and you need then what I call the fast interpreters. And there's the only way I can really explain that is by using Formula One, where each of the racing car companies goes through like 1 million+ bits of data every single race, if not a lot more. And they have people who sit there, 2 or 3 people who just analyze the data from what they see. They don't use the computers and the information. They just and I think you need that mix. I know from experience, Mark, that people will collect information around leakage, and probably Amy knows this as well, but the spikes in pH or something else, they don't pass that information on to anyone. So we need to be able to find ways to sort of pull everyone into the mix and capture it. And having it just in the IT is flawed, and the classic example is cyber. Lots of the cyber issues relate to people. So having IT run it and put all these great systems in is just a very partial answer to a complex question.
And Amy, you mentioned that you're not a digital expert; you're an environmental expert. How have you found working with the digital side of things? Is it output driven, or do they tend to be more sort of geeky data driven, or even software driven?
A bit of a roundabout answer, but it kind of answers your first question as well. I think it's just all about communication, and sometimes kind of the arts and how we communicate with each other and how you explain complicated things kind of gets a bit lost. So in terms of what skills we need, I think kind of communication is vital regardless. So yeah, I guess maybe I've been lucky with the data scientists that I've worked with, but yeah, generally we found a way to kind of communicate and use sort of simple language that everybody understands rather than kind of, yeah.
No, I think it's really interesting. No, it's really, really interesting. And there's another one that's come through actually, is about, Paul, particularly if you're talking about, what was the word you used? Mega terabytes or something else? Zettabytes.
Yeah.
With that amount of data, does that bring into play the whole carbon footprint associated with storing it, data center power consumption? When the water sector is priding itself on driving towards zero carbon?
Yeah, the simple answer is yes, and they're already beginning to emerge pressure challenges between the amount of water available and the pressure of then using that water to keep data centers cool. Where that goes is another question mark, but absolutely, and there's nothing happening with data. So the latest figure I got was that it'll be 175 zettabytes in just 2 or 3 years. That's 175 times a trillion gigabytes. I mean, it's scale of it is something you can't comprehend, but it's not going anywhere except growing all the time. And do we really understand the potential impact on water supplies and consumption patterns? No, we don't yet. We're just in the very early stages of learning what all that means.
So I give the final word to Tom. I mean, I don't know what percentage of that 175 zettabytes of data is worthwhile, but I think learning from each other is really important. And I know in Singapore you're launching the Water Data Exchange this week, aren't you? So to get people to start to upload data and be able to look across the world at things.
Yeah. For anyone that is going to be at Singapore International Water Week, we will be launching the Water Data Exchange. So initially we're focused on smart metering data. So there's a number of AMI projects in the water industry around the world. And previously running one of the the data teams in the UK looking at that data. I always find it very frustrating not to be able to share it with colleagues from within the UK, but also globally as well, and do comparisons and benchmarks. So yeah, that's something we're really excited to launch this week. And if anyone wants to find out more, then please let me know.
So look, I'm going to wind at that because I'm being shouted at here to say I've gone over, but I know we wasted 1 or 2 minutes. So apologies for that for everyone. And as ever, this topic, we could talk for hours and hours and hours. And I'd love to hear more about each of the projects that you talked about. And every time we sort of have a conversation, I can just think of more questions. And I guess that's because the area is changing so quickly and developing so quickly. So with that, I'll say thank you very much to everybody. Thanks to Paul, thanks to Amy, and thanks to Tom. And if anyone is in Singapore, please go along and see and listen to what Tom has got to talk about the Water Data Exchange, but I'm sure you'll hear anyway. So with that, I'll just say thank you to everybody, and I'll bring it to a close. So thank you. Bye-bye.